Welcome. In this example, we're going to look again at graphing a linear inequality. Essentially, there are really just two steps to graphing a linear inequality. The first step is to treat that inequality as though it's an equation. So you're going to replace the inequality with an equal sign and just graph that line. Now remember, if the inequality has a greater than or a less than symbol without an equal to, you need to draw a dashed line. And if the inequality does include that equal symbol, that means we can touch that boundary line and we'll draw a solid line there. And then the graph, the solution set, is going to consist of half of that plane. So it's on one side of the line. All you need to do is to choose any point you want as long as it's not on that line. You're going to choose a point and test for truth. And that will let you know where to shade. If you get a true statement, you're going to shade the region containing the point. And if you get a false statement, you would shade the other side of the line that does not contain your test point. Let's look at an example. Here, we're going to graph the linear inequality 4x plus 2y is less than or equal to 8. So this first step, again, we treat that inequality as though it is an equation. And all that inequality symbol is telling us is that we are going to use a solid line because it has the equal to. When we draw that line, whatever it looks like, it will be a solid line. Now, we need to graph this line, and in order for us to graph this line, we need it in the form of y equals mx plus b, because that's going to let me find the slope and the y-intercept. So this is the same as 2y equals negative 4x plus 8, and dividing everything by 2, I have y is negative 1/2, x plus 8 divided by 2 is 4. My slope, m, is equal to negative 1/2, and my y-intercept, b, is 4. That lets me know I have the ordered pair 0, 4 for my y-intercept. So I'm going to count up 4 units on my y-axis, plot my y-intercept, and then I'm going to treat my slope as though it is a rise over run situation. Remember, there's only one negative value. So I'm going to say negative 1 over positive 2. That means I'm going to rise, go down 1, because it's negative, and we will run, we will go forward or to the right 2. So down 1, forward 2 takes me to this ordered pair. Down 1, forward 2. Down 1, forward 2. I could even go up 1, which would be positive 1, and then left 2, which is negative 2. So I went ahead and added a couple more points, and now I'm going to draw my solid line. So this line represents this portion or the related equation for this linear inequality. So we just treat it like an equation, and then we draw it with a dashed or a solid line. And of course, because this had an equal to, we used a solid line. So for the next step, we choose a test point, any point we want, as long as that point is not on the line. In this situation, I'm inclined to choose the origin again, because it's very, very easy for us to deal with this origin value. So I'm going to test the ordered pair 0, 0. And that gives me 4 times 0 plus 2 times 0 is less than or equal to 8. The left side simplifies to 0. 0 is less than or equal to 8, which gives me a true statement. That indicates that this ordered pair 0, 0, the origin, is included in the solution set. And that means all of the solutions are, in a sense, in this below region to the line. Now, one comment I always get from students is, can't you just guess, less than would be below or greater than would be above? And if there is a negative in there that you end up dividing by, that would reverse the inequality sign. So you can't just assume that because this is less than, we would be shading below. So I'm just reiterating here that you really do need to choose a point to test. So here is my shaded region, and the shaded region represents the solution set of all ordered pair points that would create or make this inequality true. So any point on this side, any point I choose, would give me a true statement. And just to show you what a false statement would look like, if I choose some value above, maybe say 9, 4, I think that's 9, 4. I didn't count all my dots, but 9, 4 would be somewhere over there in relation to the line. And if I tested that and said, well, 4 times 9 plus 2 times 4 is less than or equal to 8, I'm going to get a false statement. 36 plus 8 is less than or equal to 8, which is definitely not true. So there are no solutions above the line. And so there you have it. There's our second example of graphing a linear inequality and then determining the region which contains all of the solution set.